This is 8:5 tangent ratio. So this, now we are going into trigonometry. This is really intro to trig. You do a lot more trig in algebra 2. Okay, so this is just the first intro to it, really. Okay, so let's start with the warm-up. Okay, think about, how do you find this frag height, h? Stop the video and do it now. Okay, so if you look at it, these are right angles, and this is shared. So these two triangles are similar, right? So you can set up a similar triangle, corresponding side of similar triangles are proportional. So 5 over h should equal 7 over what? 15 plus 7, 22, right? So 7h is 110. H is 110 over 7 feet. Okay, now here is another one. We want to find this h. First, let's try with 30 instead of 32. Okay, if this is 30, what is h? So you have right angle and you have 30 degree, so that's a special right triangle, right? So that's a short leg, that's a long leg, right? So then 150 divided by root 3 is 3, 150 root 3, and so that is 50 root 3. So h is 50 root 3 units. There's no feet or anything here. Oh, let's just call it feet. So this is feet. Okay. Now, if we want to see the actual height of the flagpole, then this would be 50 root 3 plus 6 feet. Remember, you can't add them. So the idea is, if this is 30 degree, we know the ratio, so we can get the height. So what happens if this is 32? Do you think we can find h? Or it only happens for the 30 and the 60 and the 45 triangles? What do you think? We got the two angles, right? And we got the lengths. So we can replicate exactly the same congruent triangles, right? You have the two angles and the side in the middle. So no matter what this angle is, you should be able to find out this length and this length, right? Because you know the two angles inside. That's where the sine, cosine, tangent comes in. Okay? So objective for A5 is define the tangent ratio for an acute angle. So later in trig, in algebra 2, you will learn tangent, sine, cosine, tangent ratios for the obtuse angles and angles greater than 180. But for here, you are only dealing with the acute angles. Okay, so here is the concept. Oh, and the sine and cosine is in 8.6. Okay, and then we do application of right triangle trigonometry. So this is more about like a real world situation, how to use these ratios. All right, so tangent of angle A, tangent ratio of this angle right here is the leg opposite of A over leg adjacent to A. Okay, opposite over adjacent. I'm sure you heard the SOHCAHTOA word. Maybe not. SOHCAHTOA. Okay, this is for sine, this is for cosine. You will learn that in 8.6. This is for tangent. Tangent is opposite over adjacent. So-called TOR. Opposite over adjacent. Opposite over adjacent. Okay, that's what it is. Okay, so tangent ratio of angle A is its opposite over adjacent. So for example, if this is 5, 12, and 13 right triangle, and this is hypotenuse, right? So tangent X, tangent of this angle is opposite over adjacent, 12 over 5. Tangent of this angle Y would be opposite over adjacent, so 5 over 12. Okay? You know the X and Y are complementary to each other, right? The tangent ratio of complementary angles are reciprocal of each other because the opposite and adjacent flips. Okay? All right? In the right triangle shown below, angle A is angle R. Then, by the angle-angle similarity postulate, the triangles are similar. We can write these proportions. A over R is B over S. Why? A over R, B over S. Why? The corresponding side of similar triangles are proportional. And if this is true, then numerator over numerator is denominator over denominator. That's proportion. So, so the tangent A is A over B. Tangent R is R over S. So tangent A and tangent R are the same ratios. That's the definition of tangent ratios. Tangent ratio doesn't change based on how long the side is. It's because it's a ratio. It's the ratio of opposite over adjacent. So if, let's say this is 30 degree, right? Then this is going to be 1, and this is root 3, right? So opposite over adjacent is 1 over root 3, and this is the same. If this is 30 degree, this is going to be 1, and this is going to be root 3 in ratio. So it's 1 over root 3. So this is actually 3 over root 3, right? So that would be the tangent ratio of 30 degree. Yeah. Okay. So if you know the angles, the tangent ratios are fixed. Depending on it's the tiny triangles or humongous triangles, it's the same ratio because the ratio of the size that matters, not the length. Okay. Find the value of y to the nearest tenth. Okay, so now we're going to use how to use these things. Now, here's a 56 degree. That's not one of the special angles. So we don't know the ratio of these sides, right? But we can find the tangent of 56 degree on a calculator. And this should equal opposite over adjacent, right? So we are trying to find out the opposite side. So opposite side is y, have to be tangent of 56 degree times 32, right? You multiply 32 both sides and you get y. So here's what you do. You get your calculator. So this is the only time that you get to round. This is the only part of a geometry class that you get to round. So you do, here's a tangent button, tangent. Oh, before you do that, make sure you go to mode and you look through here. Where is it? There's a radian mode here. Oh, here's degree. Yeah, here it says radian and degree. Make sure you change to degree. So enter, and the degree is highlighted here. This is radian and degree. When you do a trig in algebra 2, you do radians, but right now we are using degrees. Degrees is 56 degrees. 56 degrees in radian is not 56 degrees. Okay, you run that later. All right, quit and tangent. Otherwise, you're gonna get a different value. 56 degree is 1.48. That's the ratio. Okay, so and then we do times 32. So times 32 and 47.44 nearest tenth. So 47.44. 4. Now, when you round it, you have to change it to squiggle. Just like this is congruent and this is equal, I'm very strict about this. So if you are rounding, you have to change, because they are no longer equal. They are approximation. You have to change to 2 squiggles. Okay. Oh, just so you know, so let's just see. If I go to mode, right, and then I change back to radian, okay, and then I do tangent of 56, it gives you a completely different number. See, it was 1.48 before, and then it was negative 0.61. Okay, so you see, so it's important that you change to degrees here. Okay, most calculators probably preset to come in radian, and you get a wrong number. Okay, and since you're using calculator for the test, before you do, they often resets to radian, so check that every time. Okay, all right. Next page. Here is a word problem here. Okay, you can find the approximate degree measure of an angle with a given tangent by reading the table from the tangent column across the angle column. Or okay, we don't use this. Or by using the inverse, we're gonna use this. We're not gonna use the column. Okay, so this is the inverse. So you know the two sides lengths, and you want to find out the angle right here. Okay, so the grade of a road is a ratio of its rise to its run. This is called grade of the road. Okay, it's like a you know, the slant of the road is called grade, usually given by a decimal or percent. Find the angle that the road makes with the horizon that horizontal if its grade is 4%. Okay. So 4% means if this is 1, no, this is 4, this is 100. If you go 100 meters, it goes up by 4 meters. So grade of 4%. Okay. But that's the angle is not 4% or 4 degree. It's not. Okay. So that's what you have to do. So tangent of x is 4 over 100, right? Tangent of this angle is opposite over adjacent, right? So what you do is tangent inverse of 4 over 100 is x. Gotta remember this, okay? This is like taking the opposite. So, and then tangent inverse over here. Let's see what you can see best, okay? Clear. Second tangent, that's tangent inverse, okay, and 4 divided by 100, enter, and then you get 2.29. So x equal 2.29. Okay, so that's the degree of the grade, not 4%. Okay, so you have to use tangent inverse for that. And what did they say? Find the grade of the road ratios. Find the angle that road makes with the horizontal. So it doesn't say where to round it. So I round it to hundredths. If you were to round to tenths, that would be 2.3 degree. If you round to just whole number, then it would be 2 degree and so forth. Okay. All right. Here is the practice problems. 1 to 3 express the time ratio. Okay, I think these are too easy. Express tangent S as a ratio for each triangle below. So let's do these. These are homework. Okay, use a table. Now use a calculator to complete the statement. Okay, so tangent of 24 approximate to tenth. Okay, round to tenths. Round to tenth, and then so these are regular tangent and these are inverses. So you do tangent inverse of this, tangent inverse of this, and so forth. Okay, it's just a calculator practice. All right, 3, 45, 45, 90 triangles are shown below. In each triangle, express tangent of 45 in the simplest form. See the entry for tangent 45 is exact. Okay, we're not going to do that. All right. What do you think tangent of 45 is gonna be? What do you think? This is 45, right? Tangent of 45, opposite over adjacent, 1. Opposite over adjacent, 1. Opposite over adjacent, 1. Tangent ratio of 45 degree is 1. And that's why we know we don't need a calculator to do this, because it's always 1. Okay? Tangent, I'm sure it's coming up. Tangent of 30 is, let's see. So this is 30, right? And this is 1 and root 3. I just showed this to you. It's 1 over root 3. So that would be root 3 over 3. And tangent of 60 is now this one, right? So it's root 3 over 1, which is root 3. Okay? So these we know. That's why we don't need to get a calculator. The others we don't know. So we need a calculator. Okay, what's that? What else we have here? 3, 30, 60, 90 triangles are shown below. In each triangle express tangent of 60 and express, we already did that. Use root 3, find the approximate value of tangent 60. We don't need to do that. And then try for decimal places. No. Don't need to do this. What are these? This is just showing the ratios. We don't need to do this. Notice the tangent values increase rapidly towards the end of the table on the page. It does get, we don't have to worry about this. But tangent ratio does get really big. Explain how you know that there is some angle with a tangent value equal to 1 million. Is there any upper limit to tangent values? Okay, what do you think? Think about it. So tangent is opposite over adjacent, right? So the value of tangent to be really big, what does that have to be? You have to divide by, well, you want the numerator to be huge and denominator to be small, right? So if you have a grade that is like ever so slightly slanted, like this, so that it goes up 1 meter for 1 million meters. If you have to go 1 million meters for the road to go up 1%. And this angle, tangent of this angle would be 1 over 1 million, which is very small number. But if you want a huge, this is 90 degree, huge tangent number, then we gotta look at this angle, right? Tangent of this angle, which is ever so close to 90 degree, and then yet not quite. Okay, so that means tangent of this angle is 1 million over 1, which is 1 million, right? And if you have tangent of let's see, z is, it's instead of 1 million, this is like 0.01 million for 1 meter, for example. You went 1 million meters and it went up only by 0.01 meter. So then it's 1 million divided by 0.01 meter. So that means you're gonna add 2 more zeros, then that's 100 million. 100 million tangent. So there is no upper limit on tangent. It's getting very close to 90 degrees and not quite 90 degrees, because you cannot have 2 90 degrees and it's not gonna, then these are 2 parallel lines and they're not gonna form a triangle. But as long as this is ever so less than 90 degrees, it will become a triangle at some point, right? Of that angle, the tangent is extremely big. But tangent of 90 degrees doesn't exist, because then it's not triangle anymore. You don't have the side. Okay? And one more problem, and then the rest is exercise. Okay. 2 ways to find the value of x are listed below. If you want to find this value, you can use tangent of 50 or tangent of 40. Which of the following statements are correct? Which correct statement is it? Okay, I'm going to do this as a homework. Okay, read this and then think through. Okay, we're done.